Recursion occurs when you have a process or an object that refers to itself in such a way that the process or object is repeated. Computers are very good at repeating things, and one common way of doing this is using iteration, or a loop, to do the same thing over and over again. Recursion also involves repeating things, but with a twist. Recursion requires that the thing somehow refer to itself. Here's a simple visual example. Take a look at this container of Dutch chocolate mix. This can of chocolate has a picture of a woman on it holding a can of chocolate, which has a picture of a woman on it holding a can of chocolate, which has a picture of a woman on it, and so on down the line. This process doesn't repeat infinitely, of course. At some point, we reach the smallest can of chocolate. And that's exactly how recursion works. The thing, a picture, a mathematical function, a piece of code, calls itself repeatedly until some final limit is reached. A recursive function is recursive because the definition of the function includes a reference to the function itself. Recursive functions must also include some means of indicating what to do when the limit of the recursion has been reached. There are certain mathematical functions that are self-referential. They are defined in terms of references to themselves. Factorials, the Fibonacci sequence, and fractals are all recursive in nature. As a physical example, let's take a look at these Russian nesting dolls. You may have seen these before. Included inside this doll is another, smaller version of the same doll. And that doll, in turn, has a doll inside her, and so on. If we ask the question, how many Russian dolls am I holding? A perfectly reasonable answer would be, this one, and all the ones inside it. In fact, this is a response that indicates an intuitive understanding of recursion. Here's what some of the pseudocode would look like for the answer to that question. Def how many dolls, this doll. That takes a doll and asks the question of how many dolls am I holding. The answer, of course, is going to be this doll, the one I'm holding, and all the ones inside it. After we get that answer, we return that answer as being the answer to our question. This part here, the all the ones inside it, is the recursive part, in which we again ask how many for the object. Here's another way to write that same function so that recursion is more obvious. Def how many dolls n, where the answer is equal to 1 plus how many dolls n minus 1, and then return the answer. Do you see the how many dolls function calling itself again, right here in this function? That's the part that makes this problem-solving analysis recursive. Let's go ahead and go through this counting process with the actual dolls themselves. I'm going to follow the code as I go so that we can see how it works. So, how many dolls am I holding? This one and all the ones inside it. Now I'm calling the how many dolls function on the smaller doll and asking again, how many dolls am I holding? This one and all the ones inside it. This continues until there are no more dolls to open, at which point the recursive function needs to know how to stop. So we need to add another line that tells the function what it should do then. If this doll has no more dolls inside it, return 1. Let's take a look at a program written to help demonstrate this. We don't need to worry about the details of this program. We can just watch it recursing. You can see the program descending down into each doll, continuing its search until it gets to the smallest doll, the one that can't be opened. At that point, the number of dolls there, 1, is returned to the previous function call, so that doll can be added to the ones above it, which can then be returned and added to the ones above it, and so on. You wouldn't actually use a computer program to count Russian dolls, but the principle of recursion is an important one. Whether you're counting dolls, calculating a factorial, counting tree branches, calculating the Fibonacci sequence, drinking hot chocolate, or using the internet, there are examples of recursion all around us.